Hi, my name is Marc Goodner. I'm with Microsoft. I'm on the C++ team there. Our team's responsible for the C++ support in Visual Studio and in VS Code. So kind of look at both areas. We own the compiler, the IDE experience in VS and VS Code. Personally, I spend most of my time on cross-platform topics. Primarily our Linux support within Visual Studio is where I spend a lot of my time, as well as Azure Sphere, which I won't be talking about today. But if you're interested in embedded and Azure Sphere in particular, I'm happy to talk about that later. But let's talk about cross-platform C++, and it's challenging, and how can we get tools to help us here. So if we look at what are the challenges with cross-platform C++, I think that this is a pretty good list to start from. I think libraries are probably one of the bigger problems. How many people here would agree libraries are a challenge when you're doing your cross-platform development? Yeah. Some of you aren't raising your hands, and I'm not sure I believe you. But yeah, so compilers can be a challenge. I think compilers may be a little bit less of a challenge than they used to be now that standards conformance is getting better with compilers, particularly MSVC, really, if we're honest. Build, obviously, is going to be a challenge. Testing, debugging. Editing is something maybe you don't think about as a challenge because maybe your tools aren't helping you much with editing, so you don't think about it perhaps. And then finally, the one I find that's kind of the hidden challenge is the host. What's the host operating system you're working on to do your cross-platform development, and are you actually thinking about that as part of your cross-platform development tool set? Is there anything on this list that I'm missing? Is there another challenge that you have with cross-platform development? Yeah. I'm sorry? Code browsing? Okay, yeah, large code base? Okay, yeah. And you?
Probably documenting because you have different
Ah.
one system and another system.
Okay, documentation of behaviors on one system versus the other. That's a good one. I may have to add both those to my list here. Those are good. But let's talk about libraries and compilers. So one of the ways that we manage libraries when we're doing cross-platform development is with the system-provided package manager. But system-provided package managers aren't really ideal for libraries. System-provided package managers, and really we're talking Linux here, things like apt-get, they're for managing the packages that the OS is built with. And the packages that the OS is built with may not be the libraries that you need for your application. So you're going to get into a situation where you can't get the version that you need, or perhaps even the libraries get switched out from underneath you, unbeknownst to you because of a system update. So those sort of things happen. And then there's, some operating systems don't really have a package manager at all. We could look at Windows here. Obviously, there's not a de facto, there's Chocolatey, but it's not really designed for libraries. And then there's the Mac. Mac's got Homebrew, but again, neither one of these are really, from the vendor, and they may not be ideal for libraries either. And so you could manage your libraries from source, of course, which gives you the great ability that you're in complete control, and also the terror that you're in complete control, right? Because now you have to manage all of this yourself and keep track of all of this, and this becomes a full-time job. Those of you with large code bases, do you have somebody like in your team who is the person that keeps track of all of these library dependencies for you? Yeah, I see. Some of them are sitting here with us today, yes. And then, of course, C++ itself, it doesn't have a package manager. There's a lot of modern languages like Node, that they do have package managers, and things like .NET has a package manager, but C++ doesn't. There's a lot of things happening in the ecosystem today with VC Package and Conan, but there's, C++ itself doesn't have one, so it puts you in the position of having to choose how you're going to manage this. And as I kind of mentioned, compilers are getting more consistent today. Of course, you're probably having to deal with older compilers, which doesn't give you the liberty of using the standards to have consistency across your compilers, especially if you're targeting older versions of Windows where you have an older version of MSVC where you may not be able to use the latest standards. But this is a place where I think Clang and GCC for a long time have upheld to the latest standards. Microsoft, we've been working very hard to get MSVC conformant with the latest standards. So hopefully your compiler is going to be less and less of a problem with cross-platform in terms of the code that you write. You'll still, of course, have to manage the switches that you're using per platform if you're using different compilers, of course. And then build. So CMake, it's becoming the de facto build system for C++. I don't think that's a controversial statement. Most people here use CMake today. Oh, only a few hands going up. Not, oh, okay, there we go. All right. And how many of you are wrapping CMake? Are you using something else on top of CMake, like a meta system on top of CMake within your organization? A few hands going up. Yeah, I see this in particularly larger organizations, that have very large code bases and a lot of complex needs. It's not unheard of to see this happen, but it's typically very large organizations with large code bases where I see that happen. But the thing with CMake is you want to keep platform-specific info out of your CMake if you can. One thing, if you go out and look at open source code bases that use CMake, it's interesting because the older the code base, the more likely you're to find even CMake-isms in there to deal with platform abstractions that aren't really necessary anymore. So as you go forward, and you should keep track of what's going on in your CMake and understand whether or not platform-specific switches to do platform-specific things in your CMake, particularly for things like finding packages, are really still necessary anymore. And then MS Build. Obviously, MS Build is for Windows only for C++. And the reason I'm saying kind of there is you may see that MS Build is available on Linux today. That's specifically for .NET Core and .NET scenarios. We're not investing in MS Build for C++ on Linux. We're not. So if you have an investment in MS Build for Windows projects and you're looking at moving across platform, you need to be looking at CMake or something else to get your builds running cross platform. I would not look at MS Build on Linux for C++. The other thing, though, is that a lot of people take their CMake files and generate solution files from CMake in order to open the code in Visual Studio, and that's something that you don't need to do anymore. Today, Visual Studio supports just opening a folder of code that has a CMake list.txt in it and just letting you start working with it, and we'll take a look at that. And then finally, there's Make and all of the rest of the other build systems out in the world that we all have to deal with. But why don't we go ahead and start taking a look at what this can look like. And we'll start by looking at Linux. Oh, all right. I always forget this. I have to exit PowerPoint first. All right. So let's take a look at Linux. Oh, and actually before I do this, I want to show one quick thing here. In Windows 10, in recent builds, I'm not sure how recent because I'm always on fast ring, there's this thing in, I'll show this again, in Hyper-V, there's this quick create command here, and if you click quick create, one of the new options is to quick create a Linux VM for Ubuntu 18. What's really great about this option will configure the VM to use RDP, which gives you copy paste. So it gives you scalable windows and all of that sort of goodness without having to go wade through a whole bunch of documentation on the internet that may be wrong. So I highly recommend that. So here we've got a Linux system, and what I'm going to show first is package management using VC Package. So if I go into my VC Package directory, VC Package is cross-platform now. You can see here that there is a bat script for bootstrapping VC Package on Windows, and there's a shell script for bootstrapping it on Linux. Basically, you just git clone VC Package down, and once you run the bootstrap package relevant for your system, then we can go VC Package, and we can do things like search, and we can search for a library, and then it'll give us the results, and we can pick a library that we're interested in. VC Package today has, I think, over 700 libraries there. We take pull requests for port files that describe how to build libraries. So VC Package will build the libraries from source on your system. And so all that looks like is VC Package install SFML. That ran really fast because I already built it before. So it's not really that fast. It's actually going to pull the sources down and build it. But I've already done that, so that's the results it gives you. It tells you what CMake targets this satisfies. And if I want to use VC Package with my CMake, then what I can do is say integrate install. And then that's going to give me a toolchain file that now I can use passing that command to CMake, and now CMake will be able to find my SFML library. So we can take a quick look at that. We'll go in here. And this is a simple CMake demo from the SFML library itself. If we take a look at the CMake list.txt, we can see this is very basic. It's pretty close to what the CMake list.txt for the SFML sample is itself. The main change I made was basically just so that I could run this standalone without having to compile all the SFML samples. But you can see it's finding the packages, it's linking the libraries, and there's nothing here that is platform specific. And so now, if I make my directory and pass my command line, sorry. Oh, that was wrong. And so there we go. We've got that built. And then I can make. And I've got Pong. So that's how easy it was for me to grab my libraries for an application and just get started and passing that in. And yeah, I'm not any good at Pong. But you can see that it actually works. Now, I'll take a quick, let's see, let's get rid of that directory. And what I want to show you now is VS Code. And so here I've got VS Code opened up. And what's interesting with this is I have VS Code installed with our C++ extension. And I have our C++ extension configured to get my IntelliSense from this vector of bool extension, which is a CMake extension. So we're using another public extension from vector of bool for CMake integration, and then that helps us get our IntelliSense within VS Code. And so what that winds up looking like, and actually I'll show you also, there's the CMake kits. This is how I can actually pass command lines to CMake through this particular extension. So there's these JSON files that the extension requires in order to pass a command to CMake, and so you can see I'm just passing in where the toolchain file is, similar to how I just did that from the command line. And if I come over to the file, I can actually go to this definition, and you can see it actually opens up the location where that file is, and that's really small, but it actually shows that the directory that this file is in is under the VC package installed directory. So it's all configured like that. And now if I want to build, then through Visual Studio or for VS Code's command palette, I can say CMake build. That's going to build the application. And now if I want to debug, I can click the debug icon and come over, oops. You can click the debug icon and configure. And so now VS Code is going to ask me what do I need to configure this for debugging. Let's say C++. It gives me a little template here. And so I happen to know that, so in my workspace folder, this actually put it under a build directory, and the output name is going to be Pong. And so I can save that and then hit launch. And now there's the Pong game again. And once again, I'm no good, but I hit a breakpoint. So this is pretty simple in terms of getting VS Code configured on a Linux host to do C++ development, fully integrated with CMake and stuff. So if your host is Linux, then there's some great tools here for you to use. So, but if your host isn't Linux, we can come over and take a look at Windows. So here I've got another clone of VC package that looks a little small. Let's bump that up a little bit. So now I've got, I'm just in my VC package directory. So again, I've already run the bootstrap. So they created an exe here, and I can say VC package search SFML. Oops. Now we'll see what it comes back with. Yeah, there's not too much more than SFML, right? So it found some libraries, and I can do the same sort of thing. I can say install SFML. So you can see the experience is very similar across platform. It's running the same on the different platforms. And similarly, we've got VC package integrate. Integrate install. And so that gives me the toolchain file on Windows I can now use with CMake projects. Now the interesting thing is this integrate install command on Windows actually integrates VC package with MS Build projects for Windows. So if you use VC package on Windows and you run that integrate install, any traditional MS Build project in Visual Studio will now recognize any of the libraries that you've installed. But if you're using CMake, then you still need to pass this CMake toolchain file. So let's take a look at what that looks like. And so in Visual Studio, I'll go open folder. There's a CMake option. This option is the same as the open folder. It basically, the difference is the CMake option enforces that you have to choose a CMake list.txt. The folder option will open any folder of code and do its best to read it. If it finds a CMake list.txt, it will use it to configure IntelliSense. And so here I go. I've got my Pong folder. It's the exact same code. You can see here it's got the same resources folder that really just has a font in it. There's my CMake list.txt and the Pong file. You can see it's the same CMake list.txt. Now I got a CMake error here. And the reason I'm getting that error is because it can't find SFML because it doesn't know how to. So what I can do is change my CMake settings. Now when I change my CMake settings, by default it's going to try and run this as my host. So by default it just picked x64 for me. But as soon as I want to configure my CMake settings, I have to actually create a file that's going to configure my settings, and I have to pick what kind of system I'm configuring for. And so we've got a bunch of canned things here, so you can pick like what sort of target you're trying to hit, and we'll give you some configuration that matches some known good configurations or starting points for you to get started with. But we'll go ahead and do x86 debug here. And so now there's my CMake command args. So anything I pass here, put here, will be passed directly to the CMake command line. And so what I want to do is grab this and paste that in there and save that. And now it's going to generate the CMake cache again. And this time it worked. And actually let's open up the C++ file. And we can see that it works because now if I go to this document, if I open the document, you can see it found the graphics file. And you can see there it's actually in the directory where it's under my VC package installed directory, the same as it found on the Linux host in VS Code. It is now found that file. And so now what I can do is I can come in here and let's see, make sure I've got a breakpoint set. I don't. Let's set one here for where I lose the game. And so what we can do, we can set our target for pong.exe and hit run. Now that's going to go ahead and build that. Start the game. Oh. And there we go. Now we've got our breakpoint. So, you know, I can never win this game or any game really. But at any rate, so there we go. So that's how easy it is to get that configured for Windows. You know, so the same exact app using the same exact CMake file using VC package. You know, so now I've got it working on Windows or I've got it working on Linux. But for Visual Studio, I can actually target remote hosts. So I can add a configuration and I can say Linux debug. So now I can select this, and this has added another configuration to my file of Linux debug. Now you'll see here it's got this remote machine name, and it's using a default remote machine name. And so what does that mean? This, by the way, is great. This little bar up here, this is the quick search bar in Visual Studio. You can type anything there, and if you're looking especially for things in Tools Options, type what you're looking for, and it can find things in Tools Options and take you directly there so you don't have to hunt for it. But so here's the connection manager in Visual Studio. The way that you get the Linux support in Visual Studio, let's play with fire. Let's run the Visual Studio installer. Just quickly show you this. You get the CMake support in Visual Studio by default when you install the C++ workload for Visual Studio in VS 2017. The Linux support does not come by default. Please don't have updates. But let's click Modify here. I just want to show you where to find this. So if we scroll down, it's right here. It's kind of down at the bottom under Other Tool Sets. You can click this Linux Development with C++. And what that will give you is integration with CMake. It's optional, the CMake support, but it's selected by default. There's also embedded in IoT development. What that gives you is basically ARMGCC compilers pre-installed to use with our open folder support. I don't have time to go into that, but we've got some things there too. So that's how you get your Linux support. Now you can add a connection. Basically, all you need to do is give it your host name, port, username, what type of authentication you want. So you can use private key if you need to. We do support root with no password. I'm sorry, embedded devices made us do it. This is what you've got. We've got documentation on our blog about this and on docs.microsoft. But basically, all we need on the remote is SSH, GCC, and a couple of like build essentials. So not too heavy. That's the sort of things you'd have on your remote Linux machine anyway for development. Now the cool thing is when you connect to a remote machine, we now have, I think as of 15.8, we have this remote header cache. And so what happens when you connect to any remote Linux machine, we actually inquire from the compiler about where the includes are, and we go get all the includes for that machine. And that means when you pick a machine for your C++ project in Visual Studio, you get IntelliSense specific to that machine. So you have more than one Linux machine, and you select a specific one, you'll get IntelliSense for that machine. And so you can see here, we can actually take a look at what's in that folder. And here's my, all of my user includes. And it actually found my home directory because it found my VC package installation as well and pulled down my VC package includes as well. So that's what's going on with the remote machine name. You can pick a different remote machine name by just typing here. It's a little slow. But so if I had more than one machine name, then I could pick a specific one or just use the default. The default is the first one in your list. And so that's how that works. And so now I can switch my config to Linux. And what it's going to do... Yes? Oh, did I? Oh, thank you. Oh, you're right. Thank you very much. Let me save that. Now to do it correctly, thank you. So now it's actually, what it's doing now, it's using rsync. We actually have in Visual Studio a copy of rsync on Windows that actually manages the synchronization with files to the remote Linux machine. And so it's synchronizing the files over there and generating the CMake cache. So now I've got IntelliSense for this project for Linux. And so we can see that if I open standard lib, you can see that this is actually under that app data local for my header cache, where that is. And it's the same for this SFML graphics. If I open that, then that's actually going to be here under that header cache as well, under where the VC package was installed. So it got my project-specific IntelliSense as well as the system-wide specific IntelliSense. Now, one thing that's interesting, if I wanted to come in here and say, add sleep or something, come on, IntelliSense. Ah, thank you. So if I wanted to add sleep, then I could use this include, but you notice that it gives me this purple little squiggle here. And so what this is telling me is that there's nothing wrong in the current configuration that I have. I could do this, but it's warning me, Visual Studio is warning me that I have another configuration for x86 that doesn't have that file. And so Visual Studio is actually helping me, even at edit time, warning me that I'm doing things that aren't going to work cross-platform. So that's pretty great. So we'll get rid of that. And now we'll go ahead, what we want to do, one other thing, right now we're looking at this in a view that just shows the raw file system. But we actually have a view for CMake targets view that actually gives us a view of what the targets are in the CMake file. This isn't very exciting with Pong, but if you have a big CMake file with many libraries and many executables, this will give you a project view of your CMake file with the targets that you've got defined in your CMake instead of just a raw file view. And so what I want to do now is I want to configure my debug settings. Now, a lot of times the default debug settings would work with Linux, but this is a graphics app. And since this is a graphics app, I need to tell the debugger a little bit more about what's going on here. And it's a little bit of magic. This debugger command in the configuration here is basically the GDB command that's going to execute on the remote system and start the process. But what I need to do is export the display. And so I can come over to Linux and make sure that I know what display I'm actually using. So if we do echo and check my display value, you can see that, now this is interesting because this bit us for a long time, because Ubuntu 16, the display was on 1 usually, and in Ubuntu 18 it changed to 10.0. It's useful to actually check what your display is. But basically what I want to do is export that value into the process, and then semicolon separates it. So now, if I need to run commands before launching the debugger, this is how I would do it. In this configuration file, I could just separate commands that I want to execute that way. And so now I've exported the display, and now I want to select that Pong app, and I want to go ahead and run that. And so now it's building on the remote Linux machine, so it's synchronized the files over, it's building, and it's going to launch the process. So you can see Visual Studio's in debug mode here. And if I come over here, there's the Pong game. It's actually Visual Studio launched this on the remote Linux machine. And so I can start playing my game. And I can decide that I am tired of losing. So I can move my cursor and go ahead and continue. And now I've won. And that's how I play video games personally. But at any rate. So there we go. So let's go back and see what have we seen here. So what we saw we were able to use VC package on Windows and Linux to acquire the SFML library. And as I was mentioning, there's a lot going on in the package in the library space for C++. Conan's obviously another option here. I don't know as much about Conan, but the Conan guys are here. So definitely go chat with them as well if you're interested in that. And then we saw CMake with no platform-specific switches. It built on Linux. We built that on Windows. We used VS Code on Linux to edit, build, and debug. We saw Visual Studio using CMake to target both Windows and Linux. We did not generate a solution file. That was just opening the folder with CMake in it. And we saw Visual Studio debugging on Windows and Linux, and we saw platform-specific IntelliSense. So that's quite a bit of stuff. But let's be honest. Do you guys test on anything other than your host system? Or do you just test on the host and then check it in? Yeah? Do you feel guilty? No, you don't feel guilty at all, do you? Because your CI system is great, right? But, your CI system, you might get that report, especially if it's a big build, you come back in the next day and you find out, it broke because maybe you did what Visual Studio showed you there, that, you were working on your host and you had an include file that was on your host operating system that wasn't on the one of the cross compile targets, and so maybe you broke the build. But those are easy problems to find really once you see what's going on. The hard ones are when you've got a runtime error and you have to fix something, you have to figure out what's going on at runtime, right? And so then you get into the problem of, you've got somebody who was working on a Windows host, now they have to debug on Linux, they don't know GDB, right? So they got to go to the internet and figure out, how to use GDB or bug somebody else to help them. And it's vice versa with Linux devs who aren't familiar with Windows tools. But we've got some help in Visual Studio for attached to process. So let's take a look at that. So let's come back to the Linux box first. And what I want to show you is, picked another app, something more real world. I'm a little bit of a 3D printer nerd, so this is OpenSCAD. OpenSCAD is, this is an open source project. It's a geometry program, basically a CAD program, where instead of using a mouse and keyboard to define 3D geometries, you write scripts. And it's very popular within the 3D printing community in particular. So I cloned this project down to my Linux box and I built it per the instructions from OpenSCAD. I had a lot of problems with this, I'll be honest, because I couldn't get symbols. So I couldn't figure out how to debug this for the longest time. And so I'll show you what I did, and it's dirty. But I just basically, in the CX flags and C++ flags, I just put -G in there, and then I was done. So once I generated, this is a QMake project, so this is using Qt. And but once I generated and got my make file, basically before I built, I just came back in here and modified the make file so that I would actually get symbols so that I could debug this. I looked at their instructions. I could not figure out how to get symbols officially. Now the other thing, I'll just give you a preview of something I'm going to show you in Visual Studio in a second, is this include path here. I noticed this took me a while to find as well. Their source points at Qt and is kind of the standard system locations, but it's actually installed under here. And so it took me a while to figure out why I wasn't getting IntelliSense for that, because of where Qt was actually installed to. And so what I want to highlight here about this is if you run into a problem where you've got to debug something like this, as long as you've got the source code, you can just open the source code up in Visual Studio with very minimal config. So if we go here, I basically just clone the same repo here. So there's OpenSCAD. Luckily, they're organized so that there's this source file. This view isn't going to show it to me, but there's actually a cmakelist.txt here in the root because Qt uses cmakelist.txt as part of its build process. If you try and open a Qt project that has cmakelist.txt in Visual Studio with open folder, we will get confused because there's a meta system on top of it, and we're going to try and use it as though the cmakelist tells us everything we need to know, and it doesn't. And so therefore, I'm going to open this project, just open the source folder. And so now I have really very minimal config here. But what I'll show you about what I configured here is the cpp properties.json. So if you have a build system other than CMake, or you even just want to work with your source and you don't even want to build, you can use the cpp properties.json to tell Visual Studio about how to use IntelliSense for your project. So here, I basically told it to inherit this environment of Linux x64 that gives me a bunch of default IntelliSense for a Linux system, and I'm using my same remote machine name here. Now the interesting thing is if I open this, similar to what I showed you before, this is under my app data for that machine, but if I come back to my cpp properties.json and comment that out, oops, wrong way. If I comment that out, and now if I open that, I still have IOStream, but it's actually under the Visual Studio install. So this is what we used to have before 15.8. Our IntelliSense was really limited to what we knew about Linux from kind of a default perspective, which wasn't necessarily specific to your Linux environment. But now, once we clone the headers from the remote Linux system, you'll get that specific IntelliSense. The other thing, which I was talking about that I had to do for this particular project, was I had to give it these additional include paths that I had to find in the make file, because if I didn't pass these include paths this way, then it wouldn't find the way the Qt was specified. It was expecting to find these in the system location, but that's not where they're at. They're under a subdirectory under the system location. And once I looked at the makefile, I understood that the reason that that was working for this build itself was because the makefile itself was configured. Anyway, you get it. But the point is, you don't really need to do all this level of config just to debug, but I wanted this to look nice and to show you a little bit about how to configure a non-CMake project. But if all you're really interested in is just to see your code light up as you're trying to step through attaching to a process, then you don't really need to do all that. You can just open the folder of code, and then you can just go debug, and you can go attach the process. Actually, I forgot to start my process. Let's go back over there. So now let's start OpenSCAD. This is what OpenSCAD looks like. Basically, I was telling you, you write scripts, it describes 3D models, there's geometry, you can interact with it. It's a pretty cool little program. If you have a 3D printer, you've probably encountered this. There's a bunch of scripts on places like Thingiverse. But so now this process is running here, and if I come back to Visual Studio, now you'll see that this SSH option is new. I'm not sure when we added this, a while back. And the SSH option can debug remotely on Linux boxes for .NET Core or for C++. And so then you can pick the box that you want to connect to, and then it'll enumerate all your processes. And you can even filter down, and there's OpenSCAD, so now I can attach to that. The first time you attach to a process on a remote Linux machine, you will get an error. The error is going to tell you that you're not authorized to attach to a process you didn't launch. it gives you a link to a web page where there's documentation about that. There's a command you can run on the Linux box that will allow other processes to attach to processes they didn't launch. So that's one thing you'll need to be able to do to attach. But so now it's going to ask me what type, so I'm going to do native. So now we're in debug mode. Nothing's happening though because I haven't really done anything yet. Let's go find something to connect to. Probably, oops, yeah, a new window would be good, or creating a new file would be good. So I've got a breakpoint set here. Maybe there's a problem going on with new windows. And so what happens is I can come over here, and that function is connected to this. And so when I click new, now I've hit my breakpoint in Visual Studio. And so that's pretty great. And I think that's probably more realistic in your day-to-day about the sort of things that you're going to have happen, than, using Visual Studio to build and debug on a remote Linux machine may not be your day-to-day, but this can save your bacon if you've got, something that you need to debug on a host that you're not normally working with. And so I can actually stop debugging in Visual Studio and go back to that Linux box, and you'll see it didn't perturb my process. My process is still running. So I was able to attach and detach with no problem. All right. So that's that. And so what did we see here? So we saw opening a folder of just source code and configuring IntelliSense in Visual Studio to understand that source code so we could get IntelliSense up and working. We saw SSH used for attach to process, and we were able to hit a breakpoint on Windows from an app that was already launched and running on Linux. I didn't cover this in the demo here. There's another, actually, why don't I just show this right quickly. I don't have anything specific to show you for this, but it's good to know it's here. If I close this, there is configure tasks. So you can actually run these, you can configure tasks in Visual Studio and open folder projects where you can give tasks specific names and you can associate them with a specific file or wildcarded files. And that you can actually even set, a build task. So you could actually come in here and set a command line for what you want to run for your build in a task. And there's even, I believe we've got, is it remote? Yeah, so we even have remote tasks. So you can actually configure tasks to kick off a remote something on the machine that you're working with. So this gives a lot more flexibility in terms of what you can actually do from within Visual Studio while you're working. All right. Sorry I don't have a demo of something to actually do with that. I actually do more with that with embedded. So finally, this is just kind of an open-ended question about, is the host that you've chosen for your day-to-day life, developing, helping, or hurting you, or, do you even think about it, or is it just a preference? The most common ability that all hosts have is VMs to run other operating systems and to do cross-compiling. I think the real limitation there is obviously you can't run Mac OS in a VM or a container, which kind of puts you in this position that if you need Mac OS, you really kind of have to have a box with Mac OS on it. I guess that's probably most relevant for iOS development, hopefully. Because with you can probably do cross-compiling for Macs in other scenarios, but for iOS development, you're legally required to build on a Mac. So you kind of can't get out of that one. But otherwise, I think cross-compiling is an interesting subject because you can get cross-compilers for a lot of things on any host OS, but increasingly the embedded world is moving to building cross-compilers primarily on Linux. Particularly the Yocto project, I know, is moving towards a strategy of only delivering cross-compilers for embedded targets that run on Linux, and then to satisfy developers on other operating systems other than Linux, their approach is to deliver containers. How many people are using containers for build? Only a few, okay. Containers are really interesting for build. They're a really great way to describe what you need in your build environment, and get your build environment set up in a container and then build within there. And then you can actually, once you've got things working that way, you can actually take that description, use it in a CI system, or you could even check it in and other developers in your team can use it. And you've got a consistent, reproducible environment. So containers are really interesting for that. And as I say, Linux and Mac can both run Linux containers. Windows can run Linux and Windows containers. Windows containers are a thing. There's definitely people that are using them, particularly for the build scenarios for C++. If that's something interesting, I've got a blog post up about how to set that up. And then finally, there's kind of this question of your shell. I think Windows Subsystem for Linux is really great for Windows because now you've got a Linux environment on Windows. Are people familiar with Windows Subsystem for Linux on Windows 10? A lot of people. Okay, good. Yeah, that's been really great for Windows. And there's some interoperability now between that system and the Windows host that is getting a lot more powerful. PowerShell actually exists on Linux. I find that a little bit weird, but it is there. But Windows is the only place you've got CMD, which if you're working with legacy projects, especially, you're probably dealing with something that has some of those, and so that's going to be the only environment you can work with them in. But Windows doesn't, we mentioned this kind of at the beginning, Windows doesn't have a package manager story. We're kind of encouraging people to use Chocolatey is really what we're encouraging people to use. So it's unofficial, but that's kind of the package manager story there for now. I guess there's a store. But then there's, and the Mac has Bash, of course, but Mac OS, similar to Windows, doesn't have a package manager. Homebrew's the story there. It feels even less official than Chocolatey, though, personally to me, but that's where you're at. So I think these are just some kind of questions to weigh, especially if you're considering a new laptop purchase and, what host is going to be the best home for you. These would be some things to consider. So now what? So I think hopefully this has given you some food for thought. And something to talk about, particularly in libraries, go back and evaluate, how are you handling this today? Are there newer techniques that you can leverage from things like Conan or VC Package? Compilers definitely use the standards. I don't think this is an audience I have to convince of that. You probably have more resistance from your whatever your internal processes are on that than from yourselves, I would guess. How many of you are limited to not being able to use the standards in your jobs? Stuck on something older? Not a few. Okay, yeah. Okay. And then build. I think the main thing on build, especially if you're using CMake, is to just kind of periodically go through and remove unneeded platform-specific logic. Things are getting better in terms of tooling being able to handle things cross-platform. So you should question, when you see those switches for platform-specific things, question whether or not they're actually needed anymore. And then testing and debugging, just understand, what are the gaps in your inner loop? What are you not thinking about while you're in there, so that you can do better. And know how to test on all the platforms at runtime, not just on your host. It'll save you, and keep evaluating what your tools are providing there, because the tools are evolving in this space, and they should be able to help you. And then your editors, are they going to help you catch those issues before you commit? Visual Studio has some tricks there. I'm not sure what's out in the other editors, but Visual Studio, that ability to check those things between the different configs and highlight that to you is something that we've only got in Visual Studio so far. I don't think we have that in VS Code yet. And then your host, understand what it offers you and what its limits are. So with that, I think we've probably got some time for questions. And if you want to find more, our team is active on Twitter at VisualC. I'm Robot Dad on Twitter if you want to find me, or I can grab my card and catch me via email. Our blog, we're posting topics on our blog all the time, so it's a good place to even find documentation about some of the things I've talked about. Links back out to docs.microsoft for our tools. Our team is also fairly active. I didn't put it here, but our team is fairly active on the Reddit CPP forum. So if you're looking for members of our team, particularly on deeper technical questions, the Reddit CPP forum is actually a pretty good place to find people from our team. So with that, I think we have time for questions. Yeah? Okay. Thanks.
Hi. Yeah, just a simple question on the debugging. Do you have access to all the things like symbols and conditional breakpoints on your remote debugging
I think
from
we
Linux?
have. I think we have conditional breakpoints. There are some limitations in some of the breakpoint stuff because we're limited by what GDB gives us. So the way that the debugging works, we have a bridge inside of Visual Studio that called the MI engine that basically speaks machine interface to GDB and drives GDB and integrates it to the Visual Studio debugger. And we're using the MI engine on both VS Code and Visual Studio, and it's an open source project. But yeah, so some of the stuff is there, some of it's not. One thing that's not there is that performance window or the diagnostic tools window that gives you kind of the history over time of things. That's something that you only get with Windows. We don't have that wired up for Linux, at least not today.
Thank you very much for this great talk. And I really learned a lot that we can use in our day-to-day business.
Great.
I was wondering, how good would it scale if you have one dedicated Linux system where all my remote compilers are set up and all my teammates could use the same system to remote compile? Mm-hmm. Do we need separate users, or could we just have one and you take care of it?
Well, that turns into you having to manage sharing the credentials for that single user, is what that turns into. So I don't know that I'm going to advocate that you have one shared user on a Linux box, but I mean, that would be what you would essentially be doing there if you had one shared Linux box for your team and you didn't want to have multiple users. Then what you would wind up doing is sharing the credentials for that build user.
Yeah, but I was wondering if you get race conditions if two persons try to compile at the same time. Then in this case,
I don't know. I think that's going to turn into a throughput question on the build machine from one direction. From another direction, it should be separate sessions that shouldn't stomp on each other, but I can't say I've tried that. I'd be surprised if nobody's done it. I can't think of any bug reports I've ever gotten on it. If you try that and hit any issues, and I'll just share this with everybody because this is what we're always telling people about. Oh, come on. It's just easier to show this. Come on, get out of presentation mode. Sorry. In Visual Studio, you may have seen this, you may not believe it, but we do listen to it. It's this send feedback, report a problem. We pay attention to this. So if you try that and you run into an issue, I would submit it this way, because these issues do get scrutinized even by our leadership. So if you want something on our backlog we have to deal with, that's the way to get it there.
Okay, thank you.
So first of all, thank you for your talk. As far as I know, the VC package manager only provides like one fixed version for a library. And is there some ongoing effort to provide multiple versions for a library?
I don't know the answer to that question. You're right. If you just clone VC package, you're going to get the latest version of what's there. My understanding is you can run your own private VC package repositories and maintain your versions there. But in terms of like picking a specific version through VC package, I'm not aware of what's going on there. But I can certainly bring that feedback back to the team. The VC package team also, if we just go to GitHub, yeah, this one. So if we go to if you just go to GitHub to the VC package page, VC package is developed in the open, so you can check the issues here or get in touch with the people that maintain this directly here and search the issues or submit one if there's anything missing.
Yeah, I have a small question.
Just a moment.
Yeah, actually, our team tried to open directly CMake list TXT from Visual Studio, but for some reason we failed to build it, and we still need to use CMake to generate projects and solution. I don't remember for sure what was the reasons of that. Maybe that because of Ninja build system, which is used in actual Visual Studio by default. So maybe you could just advise how we can smoothly transfer to this instead of generating it every time.
I would suggest the thing I showed you with submitting an issue, I would try opening that project again, and if the same thing happens, use that report a problem in Visual Studio, because that'll give us some diagnostics to figure out and to be able to get in touch with you, provided you allow us to get in touch with you. I think the feedback allows anonymous or with contact info, but that would be helpful to us to figure out what's going on there. It also kind of depends on when you tried. I know that on Windows, our default generator that we use on Windows now is Ninja. It didn't used to be, but now it is. And CMake is an area within the Visual Studio team that we're still investing in very heavily. So we've done a lot of work in the 2017 timeframe. So what we had for CMake, like in the earlier part of the 2017 lifecycle versus where we're at now at the end of the 2017 lifecycle is very different. We invested in every single release, and we're actually doing a lot of work for Dev 16 for the next wave of Visual Studio. We're still continuing to invest in the CMake experience. So.
By the way, great talk. I learned a lot today. And just a question about the edition of Visual Studio. Do you need a professional or an enterprise?
Nothing I showed here is specific to enterprise. Everything here is in community and above. In fact, I believe I'm running community. Let's see. I almost always run community personally, which is finally going to bite me. Okay. But yeah, so I'm using Visual Studio Community. Yeah.
Okay, great.
Yeah, kudos to you guys. You did a great job. I have a question. Do you have any experience with ROS? And if yes, how is the Catkin support there?
With ROS, the robot operating system?
Exactly.
I don't have a lot of experience with ROS, but I'm actually friends with somebody at Microsoft that's working on ROS support. So if you want to catch me after the talk, I can give you my card and I can get you in touch with him.
Great, thank you.
Okay. No more questions? All right. Thanks, guys.